Hello.
Hello. I guess we are started. All right. I'm Odes Carlos Carloskes. I'm gonna be the host of Hall One today. Later on, there's gonna someone help me. And today we have Max Körbächer. I'm sorry if I pronounced that absolutely wrong.
All
You
good.
definitely will help me in a second. But Max is a co-founder and cloud native advocate at Liquid Reply. He definitely will tell more about himself in a moment. But the things what Max will tell us about is the so popular platform engineering. There's going to be a big conference in something like 2 weeks. By the way, Max, are you presenting there as well in a platform con?
Yeah, I will also have a session, so I will be up there too.
Nice, nice. But today here we have the opportunity to get you here, get a little bit of your shining thoughts and opinions. So without further ado, feel free to take over, share the
Sure,
screen if you're ready.
I'm ready. Feel free to put the slides on. So, my name is Max Körbächer. No worries about the pronunciation, very difficult. Too many U's and S, but yeah, can only happen in Germany, I think. Yeah, I'm co-founder of Liquid Reply. We do all good things about cloud native implementations, platforms, cross-cloud, FinOps, microservice development. But we always have some feet in the water holding on the Kubernetes part and the whole ecosystem around it. Like this is our single point of contact. If I'm not working on that topic, I'm very active in the open source community. I recently got appointed as the CNCF ambassador. CNCF is the Cloud Native Computing Foundation, where I also have founded the technical advisory group for environmental sustainability. So a difficult word. And I also joined the Linux Foundation Europe advisory board as one of the members to give here the European perspective on open source and what are the relevant next steps. But yeah, enough about me. That's the most boring part, I guess. So DevOps is dead yet, right? There's a quite famous meme on the DevOps and platform engineering side. I think run a couple of times through all kind of relevant newsletter and blog posts. But I think this picture is very much wrong. For sure, like if they're children playing together, sometimes do not like each other and bully a little bit each other. But I think here it's really not the very true picture, because platform engineering is more a kind of evolution. And if you're well aware, there's a couple of dozens of different kind of monkeys running out there, but theoretically we're also some kind of monkey. So this is what evolution actually means. There's spreading out a new kind of something. And this is what we see also with platform engineering. You maybe even remember way back, there was like the cross-functional teams popping up. And then at some point we were discussing about CI/CD and we do now all the good DevOps thingy. And then Google published their book about site reliability engineering. And well, now it's platform engineering, or in the recent years, platform engineering. Surprisingly, this term is actually quite old, and we'll come back to this in a minute. The reason why I'm talking today about it is we work a lot with enterprises together. We build for them platforms. We teach them on how to build platforms on different kind of open source technologies. But what we also see is like the modus operandi within these enterprises has always a project focus. And this is so deadly. Why? Well, you have restricted times, you have restricted money, and typically you deliver only once an expected outcome. Methods as Scrum and Kanban actually try to work around this a little bit, saying like, hey, if you have a a development process, if you keep it a little bit more flexible, you can adjust on the way what you want to develop, so that after a couple of years of developing, it still suits your expectations, because expectations will change. And in general, this idea is great, right? Changing what you're doing while you're building it is perfect. But the thing is, then don't make a project out of it. Then establish a full functional team. But we see too less companies really take the step into this direction, because it's also difficult to find people who have the right skills. And the given teams, which you often find in companies, they often have just a support function, and just like is quote unquote. It's I do not want to be disrespectful, but this is a reality. An operations team, obviously, for some obvious reasons, just nailed down to ops something. They are not there to run back and forth on the round and build something totally crazy new, even so they would have the knowledge about maybe doing some things better if they have some ideas of doing some things better. And when we take a look on the terminology of DevOps, the reality is that dev is written very, very small, and ops is written very, very big. We see this at almost every customer. And the reason for that is also, again, quite simple. The term is not very much protected and was never very much defined. If you have read the Phoenix project, there's a very nice example of what DevOps in its center is. There's this part of the story where basically the whole IT is burning down and everyone depends on one single person. Taking this person out of the responsibility and put 3 more people into this and let this experienced person teach the other 3, allowing them to widen the bottleneck, allowing that one person can get sick, allowing that the one person maybe is on vacation or parental leave or whatsoever. Now, it's expected that it is like this in most organizations, but it isn't. But DevOps would be like this. If you would leave the culture behind it, then this would be something where you're looking out for. The experienced one teaching the unexperienced one and doing very critical jobs. Trust in your colleagues, practically. But we're looking always into just operations. And that's why it's important to get better on the whole operational part and how we can support you. On the other hand side, for those of you who are a developer, and unfortunately I cannot see your head bumping or nodding or whatsoever, but there's this very, very interesting chart from Daniel Bryant. Also very great white paper. I can recommend the State of Platform Engineering report. It's very good in the summary of all these things. What you can see in the horizontal lines are different layers, like the technologies that we are expected from developers to know, the developer responsibilities, what do you have to do with it, but also like on which infrastructure it is running and what is the application architecture. And what you can see over the years, that it's getting either more or it's getting more complex, right? I remember when I started in the IT around 2010, my life was super easy. You had your virtual machine, you did there somehow your little thingy, you got your application, you installed it. The process was painful. Yeah, you expected like a week or 2 weeks to set up a mail server, but then it was done and was running. And that's it. But 5 years later, actually 6 years later in my case, I worked in a company where we introduced, I think at this time, GitLab CI. And we run CI/CD pipelines the first time. My goodness, we made a big party when we had the first time a full deployment of an application automated. That was great. That was awesome. But oh boy, it got so complicated after a while. We introduced so many other tools into this pipeline, so many things which we have to learn. We started a huge transformation project. We wanted to cut the biggest, most relevant application into minor microservices, migrate them to either a cloud platform, or at this point in time, we started with Kubernetes on-prem with petabytes of block storage. NetApp even didn't have a good storage controller at this time. And Apache Kafka was not able to run in containers, so we started working on this too. So it was very crazy. And at this point in time, we saw a lot of people failed in doing their job. And I do not want to blame anyone. I was like struggling so much. I think I came home and was reading and learning in the evening as crazy. so that the next day I can have the feeling of doing some steps. And I'm not even the developer. I was just like doing some architecture and run the team for all the thing. And this pinky curve, which you can see here, this is called the cognitive load. You maybe have heard about it in the last year quite a lot, because this term is getting quite often used, meanwhile, in the context of the responsibilities of developer running on a platform and developing an application. Cognitive load. This doesn't mean that developers are not able to deal with all of these topics, but it means that most of your brain power is used for any other thing which you don't, well, not necessarily directly create any value, but you can't focus on developing the features and functions which bring business value, which move on your application. And this is a little bit paradox, because we're talking about, we have automated everything. We talk about GitOps, progressive delivery, cloud platforms, where with a snip of a finger, you get whatever you want to have. Everything is highly scalable. Deploying a new country, no problem, just go for it. And yet we are still slowing us down by ourselves because the cognitive load is so high. Okay, Max. Nice. Maybe you have experiences too. But what is platform engineering? Isn't it just DevOps doing something differently? Well, there's this very nice report from ThoughtWorks, the tech radar. You maybe have seen of it. And this phrase I have copied out here out of the context of the rest of the whole thing is from 2017. And yes, it's a wall of text, but I shortly want to revisit with you this text because there's so much truth in it, how it is today. And I mean, it's like 6 years later. So what ThoughtWorks authors have written is like, some organizations have tackled this challenge by creating platform engineering product teams. They're talking here about the challenges of starting this automation and actually what I have described before. These teams operate internal platforms, which enables delivery teams to self-service deploy and operate systems, not operating systems, operate systems with reduced lead time and stack complexity. Now, internal developer platform, you might have heard of this term already. That's used today quite often for describing those platforms. I'm not a big fan of it, but it's the best description you can find, IDPs. And self-service and operate systems. These are quite small words, nothing big to interpret, but very interesting in terms of what we're actually building, because just to build a platform to operate something sounds almost like, hey, you build a new platform as a service, maybe a new cloud provider, right? And then the second part is about the emphasis here is on API-driven self-service and supporting tools with delivery teams still responsible for supporting what they deploy on the platform. This API-driven self-service is what enabled us with a cloud provider, but also meanwhile with private cloud platforms that you know it on OpenStack and so on. And delivery teams still responsible for supporting what they deploy onto the platform. This is the perfect definition and distinction between DevOps and platform engineers. I deliver you the platform where you as a developer or as a DevOps can operate on your application. That's all the magic between it. That's why DevOps is not that. It's just one part of the whole story. So looking at the key aspects of platform engineering, when I try to boil it down or explain it to someone else, I always lay on 3 key points. That we design and build tools and tool chains, which natively fits together. No scripting. The more scripts you have somewhere, the worse is your platform. Establish workflows. And one of my colleagues said once like, oh, I feel more like a process consultant. I'm designing processes, how something needs to run through a system. But this is so true. This is actually what we do. We think about the whole process, which is more or less suitable for all kinds of software. It's not always fitting. We can find there exceptions, but most of the time, 80-85% of applications which we migrate and move to platforms doesn't need any specific. And we need to enable self-service capabilities. Now, the self-service capabilities is actually also quite old story. the big hope was like, hey, we have a cloud provider. Now everyone can go and develop their own stuff, and it's all maintained by the cloud provider, and we don't need to do anyone who's doing operations and whatsoever. But the story is that most people will fail on it, because looking at the cloud provider as Amazon, you have more than 250 services. All of the services have a couple of updates per year, maybe 10, maybe 15. You cannot keep up with the speed of the cloud provider. In no way, except you work all day long with it, you cannot keep up with the speed. So platform engineering is here, yes, again, to build a kind of abstraction layer. And it's getting sometimes very ridiculous if you think about that the cloud provider is already an abstraction layer for virtual machines, which is an abstraction layer for bare metal. Now we're building on top of that another abstraction layer to abstract away the complexity of all clouds. But I think this is how actually the world is always going to try to make things more simpler while it's getting more and more complicated on the bottom. So the final statement for me is, as a platform engineer, we provide an integrated product that covers all operational needs for the entire lifecycle of an application. The funny thing is you can read this line by line. We provide an integrated product, because this is what we actually always do as a platform engineering team. We are also a kind of product team that covers all operational needs, whatever you need to do for maintaining, running, keep alive your application for the entire life cycle of the product, but also of your application, So no worries, I don't want to show you my vacation pictures. Well, actually it's one, but this is a picture from Netherlands when I was there with my wife for visiting actually an open source conference. And we enjoyed the weekend to go to the beach, and we end up in a beach bar, want to drink a coffee. And what was quite funny is like we enter the bar and there was a sign written like, hey, please wait, we will seat you. The first waiter looked at us and just passed by. The second waiter turn, come back and said, oh, you can take every seat which you want to take. All right, fine. We took a seat. Then comes the third waiter and said, oh, we'll bring you the menu. Well, I discovered that there's a QR code on the table, which is kind of usual in Netherlands. I scan it. Oh, it's a menu, and I can order online. Perfect. Nice. So I started building the menu, which I wanted to have. My wife selected some stuff. I wanted to order also a salmon sandwich or whatsoever. It was not there. The app said like it's sold out. And while I struggled a little bit with the process of paying, because the paying provider didn't look that serious, the waiter came and asked us what we want to order. So I practically read the basket items which I've put in already, and like this, and this. Also asked if I can have a salmon sandwich. And I was like, yeah, sure, run off. And after 2 minutes, she come back, sorry, we do not have a salmon sandwich. Something which I know or guess that it's not there. So I ordered something else. After a while, she brings the drinks. After some more time, she brings some food. Why this is relevant? Why this stupid little story? Well, this perfectly describes the kind of behavior or the kind of relationship between platform engineering and DevOps. The waiters are in a DevOps mode. They're running around looking like, oh, there's someone new. I need to bring a menu. I need to ask them what they want to have. I bring them what they need. And you have also some people in the bar and also some people in the kitchen, right, who process food and who process drinks as they need it on demand. On the other hand side, someone put all those processes in just a simple platform, writing some app and saying, like, okay, you're on this table, you want to order that and that, here you can pay, order it. And then the DevOps come to execute and deliver you the drinks and food. And this perfectly actually describes, not perfectly, but very good, describes the relationship of when we build platforms, we're running platforms, we are platform engineering teams, and how DevOps are our users, our end customers, to make the real end customers, the people who use the applications which we are built, happy. So that's why you need to see a picture of the beach in Zandvoort in Netherlands. But I hope this example makes it a little bit more clear when I'm talking about this relationship and where there's really cut in it. And Of course, nowadays it's also getting more complicated when we build these platforms. We looking into building cloud native oriented platforms, which brings a certain kind of complexity. So we design for automation, we build for scalability and resiliency. That's sometimes not that easy because scalability you can do meanwhile in so many ways. You can just scale the infrastructure, you can run serverless, you can scale the containers, you can scale on edge deployments, you can scale event-driven, and so on and so forth. And there's hundreds of different flavors in it. The cool thing, and that's why we also focus so much on Kubernetes, is that with Kubernetes, we have a unified API. I do not care that much about what we have there. Just tell me what you need. And I find you a solution which natively integrates with this platform without any weird scripting or whatsoever, and provides you the service which you want to have. Handle state with smartness and care. We often see these discussions on like, hey, if you build this platform cloud native in Kubernetes, I have read it's stupid to run databases. And then you have someone else come to you, well, we run databases in Kubernetes and it works well. Well, the thing is, it depends on your capabilities, if it makes sense and if you can do it, or if you should focus on something else. Again, not to be disrespectful to anyone, but running a very huge database on Kubernetes is in theory very simple. Practically, if you think about backing it up, restoring, keep the things up and running in some way, it could get very complicated. And that's why you need to have smartness to say and cut in some point some capabilities out until you reach the point where you're able to do this. And obviously, everything must be self-contained. Self-containment is here also very relevant. I'm sorry. Shouldn't drink too much water at once. So we have discussed now about the platform engineering as the team. We have seen that when we talk about platform engineering, we talk also about people, processes, the capabilities which you are able to do so. But often we get then also the question, what is a platform? And I need to agree, to call something a platform is super horrible. Because practically everything can be a platform, right? We're talking about cloud platforms, we're running platform as a services. Meanwhile, there are some very interesting software as a service solutions, which are itself also a platform. So using the word platform is like everything and nothing. But the Technical Advisory Group for Application Delivery has recently published a white paper. Actually, you could just read the white paper and skip my talk, but sometimes it's nice if you talk with someone. And they have defined all these different layers from a platform perspective and try to put it into something which is more easier, more relevant to understand. And this graphic looks quite simple, right? If you have ever seen the CNCF landscape of all open source tools, it's super complicated. This one is lovely to go. Do not ask about the tool choices. There could be also other tools written. I think it's just like a representation. But here are a few very interesting things defined in this picture on the left-hand side. The first thing is on the bottom, capability and service providers. I love that. Why? It doesn't restrict us to any kind of cloud provider infrastructure. As said, there are very cool global scaling services and solutions. Why you can't integrate in your platform, like, for example, PlanetScale as a database, or the service from MongoDB, or other kind of services. Like, why we need to restrict ourselves just to the infrastructure? So understanding the infrastructure is just like a service which provides some kind of capability is genius, because we can really think about like, oh, do I have these capabilities in a cloud? Do I have these capabilities on-premise, in a private cloud, whatsoever? On the other hand side, on the top, you see the product and application teams. And they are also quite relevant to us because they are the end users. They are interested if we do our job very good. And these app teams, this also means you as a developer. And the funny thing is, we quite often discuss here on this point, like how a developer wants to interface with the portal, with the platform. And there are 500 answers to this. Some just wants to have a CLI, some just wants to run a Git bot, some wants to have a portal, some just need some documentation. The truth is you will need everything most of the time. You can focus yourself on just one single service which you can deliver on this point, but people will be most likely unhappy. And if you lose them, they will not lose the platform. They will spread negativity. They will be toxic to your platform. And very soon, your whole platform which you're going to build will be partially poisoned because you have a poor adoption. That's why I also said platform engineering teams are product teams. You build a product needs a happy customer. The happy customer is a developer. If you do not close the cycle, you have a problem. And then we have all the different platform capabilities. I don't want to go too much in details here. I guess there's like 1-2 boxes also missing, and there's a few hundred tools which we can put in here. So this is definitively something which we can talk at other conference talks, workshops, whatsoever, because we really would need hours for this. However, if you think about the platforms, again, quote unquote, because platforms are so widely spread, we need to think about what makes a successful platform being out there. So treat the platform as a product. I know I told you, but hey, treat your platform as a product. User experience is relevant. And this can be in any way. Nerdy and dirty through the CLI, having a nice fancy portal like Backstage where you put your ready to deploy components, middleware components, and have documentation. You need to implement some kind of documentation and onboarding processes. We had once a customer where we run with a Git bot who guide you through the onboarding process, but actually kind of fun, but for many people too slow. You need to have the self-service capabilities and reduce the cognitive load for users. This is the ultimate load or the ultimate target, not the load, which we put to any of our teams. It's difficult to measure, but when you have a development team which is speeding up in the development cycle way more than they typically would do, then you're on the right way. And just ask, get feedback, get some information from the people of the platform if it's really helpful or not. You need to be able to provide options, and it needs to be composable. I will also talk later about it, but the thing is, in a cloud-native environment with all the open source tools, you have a couple of hundreds of open source solutions. The open source world works like this. I have one problem, I have one solution. Most of the time, if I have a solution which solves more than 5 different problems, they are either not very good solved, or the platform is not very much used by the end users because it's getting, again, complex. On the other hand side, people do not like if you build a platform with 500 different integrations, right? So you need to be able to adjust your platform to the needs, and not every component needs to run for every product. That's why you need to be able to provide options here. And yes, we need to be secure by default. This is my favorite point, not because I'm a security nerd, but because in a cloud-native environment, security makes fun to implement. It's so easy to get a very good standard, a very good level of security that I almost would question everyone who would not do it, why they would not do it. It's so relevant and so easy to do and so much fun. So summarizing this up, forget about the wall of text. For me, it's more relevant the image which is there. You can see the platform engineers are running this whole layer. And you can see the DevOps are rather running on top of this platform and touching the application. This means like, hey, I take my app, I take the platform, I will integrate my application, I will deploy it, and everyone is happy. Or also, you can see it on the right side, the DevOps, going bottom down to the infrastructure. Because yes, you still need someone who's operating also the infrastructure and take care about it. On the other end, site reliability engineers going way more up to the application, pinch through it, and being able to really also fix some code, fix some flows in the application and make it better. And yes, also platform engineering is a little bit cherry picking because we don't do operations of the platforms, at least not of the infrastructure. Of the platform, yes. Of the infrastructure, no. So have a happy life without doing too much ops is also good reason to do platform engineering. So bringing it all together, platform engineers try to offload developers and DevOps from all the cron complexity of the past years. And yes, as platform engineer, we use DevOps practices to build platforms. So we somehow inherit this. Maybe now some people will say like, okay, awesome, fantastic. I have understood there's a difference in it. Maybe we can do something, rebranding our teams, whatsoever. But how and why I should invest in platform teams? What does it bring me? Well, we looked into our customers of the last 4 years, almost 5 years. And these are the 4 KPIs which I can share with you without any problem. At almost every customer, we reached that the application lifecycle has improved by 1.5 times. So we're 1.5 times faster. This is comparable with standard CI/CD solutions. Right? We had a customer, and we have a couple of customers, which have a 10x factor, and we have even one customer who has an 18 times factor. People required 3 months to deploy a new version of the system. We cut this down to less than 5 days, just because we introduced the platform for doing everything around it. And they use the same platform for other tools, for other solutions, right? It's not that it's just right size for this one, it's for the whole company. Maybe relevant for you, reduce the dev cycle error rate. There's a very nice little research from our friends at Gitpod who found out that like 30% of all developers need around 2 to 4 hours per week fixing the development environment. And this goes all the way up to 10 hours. This is crazy. This is a lot of time. Think about this, that each of you need at least 1 day per month to fix your dev environments, if you believe it or not. But it's just sometimes running updates. It's just sometimes fixing the passes. It's sometimes like, I don't know, some tests doesn't work locally whatsoever. Platforms can integrate with your dev environments if you want to. We can provide you, for example, dev containers right into your development environment, or we can spin up for you some dev environments on the cloud provider, providing always running development environments. By nature, we introduce also cost optimizations. I told about this earlier in the beginning about scaling and scalability. As we also do FinOps, we know the best practices how to scale the platform. We run every kind of platform for our customers, not on like having 20% headspace. We're good if we're running on 95, 97% of full workload on a platform. That's where we can go best. And we give on the platforms also enough flexibility to scale practically to 0 if there's no one calling, and scaling up to answer questions of a customer in enough speed and time so that still someone would not drop out of the process. But this whole procedure can cut your costs at least by 20 to 30%. And you can do way more if we take a look into some specific points where we really can screw out more money. And we have a cron reliability. So practically no downtime. We have there a couple of very good experience, and I've also talked with other platform teams, which are a product teams and some customers of us, Wherever else the platform reaches some kind of majority, the downtime practically dropped to zero. Yes, we saw this also partially with DevOps teams and their processes, but because you have the collective intelligence of operating platforms in the best way, we can really optimize here for keeping things up and running. As I said, a platform is there for running applications, so therefore it needs to be also there for 24/7. And we do this through autonomous processes. Everything in the world can stop, but as long as the application is somehow running and our platform has the right autonomous procedures running, it will be still able to answer requests and can store requests if there's any other connections lost, for example. So our lessons learned from enabling platform engineering teams. First, don't build everything by yourself. And this is actually quite funny because from my experience, platform engineers are very dedicated to their job. They love to engineer, they love to reinvent things. But we see a lot of misconceptions about it that, if there's no solution out there, I will build it fast by my own. The thing is, typically, the open source community will be way faster in building something, which is 10 times better than what you will build. So I would really, really push always into the direction. If you need something which is really, really not being out there, maybe find other end users to build it together as an open source product because it will get better. Or maybe let someone else search for a solution, because from everything what we have replaced in the past years, from custom controllers, for example, in Kubernetes, we always found a better solution in the open source space and once in the commercial space. Doesn't mean that you should not build it by yourself all the time, but be careful what you're going to build by yourself. Platform teams are not a project. And I've said this now 20 times. Platform teams are a product team. They need to continuously run. We always see platform teams and customers getting budget cuts, like, you need to deliver this and that, and you cannot get money for that and that. Find a bucket of money for the team, fixed size for every year. Let them do their job. Because if the platform is running, you will save money in the development cycle, in the maintenance of the platform, in the downtimes, and so on and so forth. And if your platform team is good and have enough headspace, they can take care about also optimizing the platform for reducing costs. They will not maybe being able to fully pay them off by themselves, but they will be able to reduce the overall costs. And this is very helpful. You need a commitment and to give freedom. This is something which is like, you see, especially in the big enterprises in Germany. Some people, they like their job, but that's it. They do not have a commitment to it. They're not interested in fixing a problem fast or doing something else. Again, no hate here on the people, because you have this time in your life and maybe you're bored of your job. This is all fine. But in some major enterprises, if you want to have a platform engineering team, you need to find the people who have the interest to work and dig down into this topic as much as possible. I'm not talking about over hours. This is bullshit. But I'm talking about someone who's dedicated to this topic, who's interested in loving it, and who is willing to find always a solution. And then, if you see this commitment, you need to give the freedom for them to test things out. The most horrible thing which you can ask for is like giving me your blood, but you are not allowed to do anything what you think is relevant. Most of the time, the people which we have seen in platform teams, are genius. They're engineers, full-blood engineers by heart. They want to try out things. Get the commitment, give them the freedom, and you will get the best platform which you can find out there. And then things are changing. Why this is relevant? Well, because companies work like this. You have invested money to develop a solution. This is something called an asset. It has a value, even if it's digital. And if you throw it away, it's like you burn paper money. Get rid of the thought. Because how you need to think about this is more like that the solution which you have built has a very high level of inflation. Some of the solutions are long-running investments. CI/CD platforms, for example. They're built since 10 years and they are still there, they will be there in the future and so on. But some solutions are getting quite fast replaced. Still, I would like to see you all, but who of you have run an Elastic stack? A lot of people. Who of you do not run today an Elastic stack? Why? Because we found there an evolution. Elastic has going into a niche, again, no hate here, where it's just relevant for a very specific amount of people, while for the most of the time you need something more lean, simpler, faster, easier to maintain, run, and giving on hand to the people. So there is a change in the evolution, or again on this process, right? So get rid of the thought of like you have thrown away something. No, you have gained knowledge. Your team has gained knowledge. This is where you grow the value. Your team, your people now understand now how to run complex observability tools, for example. To run now simple observability tools is ease. So to slowly close up the story, here's another thing from ThoughtWorks, actually from the same report, saying, and this is, you need to listen, organizations that consider establishing such a platform team should be very cautious not accidentally create a separate DevOps team, nor should they simply relabel their existing hosting and operations structures as a platform. This is a big no-no, because your existing platforms most likely are not designed for running all the kind of applications. And I'm also here not talking about having one single platform. Don't get me wrong. Typically, we have one framework for a platform, and we can run multiple platforms setting up similar to each other. But what we can't take is a platform from which a team has built and use this as a blueprint for running other applications. This is not working because DevOps is a silo. You're thinking about your one structure. Platform engineering is a platform for everyone. And you cannot produce a silo for other applications. So platform engineering might be the black sheep in the herd of all those kind of automations. But again, it can help you to make applications run way better, way faster, way reliable. And I think I gave you enough examples of it, but having a platform engineering team will break your silos internally. It will have and requires that you run an internal kind of community and have a big exchange and big communication between your teams. So if you don't have a platform engineering team, you should grow your own one. And here's a short checklist for you for building a platform engineering team. First of all, provide an environment outside of your organizational bullshit. Why? Again, a platform engineering team also designs processes. And there's nothing worse on this planet than organizational processes of a cron enterprise. But you can do it better. Have a clear vision and target for the team. We had once a request of like, hey, can you do it better? Better of what? What is your quality criteria? Do you want to be faster, more secure, more beautiful, more, in German we always say clicky bunty, like colorful, clickable, whatever things? Or do you want to have it more nerdy, or what is better? Give a space to grow, budget and time. And this cycles back to like, don't think about projects. Think about a cron product for your internal environment that needs space for doing that job. It's not a service function. It's not an operational team. It provides you the platform for growing and enabling and generating value for the developers who are using this platform. Give up your project mentality. There's no time limit, time budget whatsoever. Just get the things done. And always do the best. So, thank you very much. If you have any kind of questions, please write them into the chat. I'm very happy to answer them. You can also reach out to me on LinkedIn and Twitter and GitHub, or if you're in one of the open source chats at CNCF or Kubernetes or whatsoever, also happy to connect and chat with you more about it, or maybe we'll see us somewhere around it. Hosting also a couple of meetups, for example, in Munich, and also being on other conferences. So thank you very much.
Yeah, thank you, Max. Thank you. That was very interesting. So while people are thinking about their questions, there are a few in the chat already. It caught my attention, the composition of roles. There was a slide like that. We in Latvia DevOps and Agile community have been discussing the concept of platform engineering for a while now, like a year as a minimum. And there are different opinions. Is the platform engineering replacing the DevOps? Is that the new DevOps? There's also SRE, which was supposed to improve the operational side of DevOps. And again, different opinions. What really SRE is. Is it an addition or is it a replacement, and so on? But then I found your picture particularly interesting, that there's platform engineering, there's DevOps, there was another DevOps, and there was a SRE team. So, and I see that Andrei Adamovich has asked in the chat, he's one of our speakers at the conference, by the way, and he's asking the following. How do you go about these titles in your organization? Is there a difference between platform engineer, DevOps engineer, or SRE? Is there any confusion?
Oh yeah, absolutely. That's a very, very interesting topic. So for me personally, I always search for DevOps engineers, I search for Kubernetes platform engineers, and I search for cloud consultants. For everyone who starts with us as a DevOps engineer, I always tell them, like, look, listen, I'm searching for DevOps to teach you platforms. So the reason behind it is, as I also explained, DevOps in many major organizations has really the high focus on operating something. And we cannot provide this as a service. This is one hand side. That's why I want to get rid of it. But on the other hand side, in the training and in the education of my team, when we're looking into DevOps, we start with CI/CD pipelines. We start with like, okay, how do you run the modern Git development cycles? How do I have to do systems administration? With the platform engineering team, I start on the other end. I start with Kubernetes, with container. How do I understand it? How do I build Kubernetes platforms? And then I come to the point of like, okay, I use infrastructure as a code to provide it on a cloud provider. And then I think about how to automate it, right? And for SRE, we have even 2 colleagues in our team, for example, who are dedicated for getting SREs or becoming SREs because they're quite young. We practically always start from the perspective, what does the application need and what does the developers need to have more insights during the development cycle? So we're talking about DORA metrics, for example. We're talking about, okay, being able to write software. So we see that there's a clear difference in it. And yeah, there's sometimes a confusion in it too, because if you have like a senior platform engineer, a senior DevOps engineer, and a senior site reliability engineer, they all know the same, but they have maybe a different focus, right? So that's why there's a confusion. But on the way, on the learning path, the paths you take are different.
Okay, thank you, Max. There is a pretty long question from Egil Svernaus. I will not read it all through, but to summarize, it is somewhat a concern that there's a lot of new stuff coming in pretty much every month, and those engineers, it's impossible to be on the top of everything what's happening. And then if we go back to platform engineering, which is another new thing, we just learned Kubernetes, and now there's platform engineering. It's 2 different topics.
Yeah.
So the question I want to ask you as the last one today, when should you start looking at introducing platform engineering concepts in the company, in organization, maybe in the project? But let's avoid that discussion. Because is it so that you have startup of 5 people and then you do platform engineering? Probably not. There needs to be some thinking behind that.
No. So, I mean, if you look at the most successful platform engineering teams, they are digital native teams which run very, very large digital products, right? But this comes from because they're digital native. Their key business is IT. Where, in my opinion, it really makes sense to start with is if you're a major organization which have dozens of applications. We have one customer where we get asked to migrate over the next years around 4,500 applications, right? You cannot do this with manpower or womanpower. It doesn't matter what you do. It doesn't matter how big your organization is. It doesn't matter if you want to throw there 10,000 consultants or whatsoever. It's simply not that possible to do so. Where it is possible to do so is if you have a production or if you have an approach which is repetitively for every of the application. Again, I'm not talking about the 5% which has very, very specific demands and not about the 10 which are super critical, but I'm talking about the other 85%, which in big companies are almost, and I'm sorry to say, but this is a reality, non-critical, not that relevant. It's just a simple web application, a simple backend service, which doesn't do that much. I don't need to do for this like a 5-week transformation thing. I can look on it, I can rely on my platform, on my automation, I can introduce it and then lift this to the platform and migrate it somewhere else. I think this is the most relevant use case where it makes sense to look in platform engineering. If you have one single big application, you most likely have a DevOps team around it, and this will work perfectly, right? I've recently spoken to a bank here in Germany, a fintech startup. Same discussion. Oh, why we need platform engineering? We have a DevOps team. Yeah, how many other systems do you have besides your banking application? Yeah, well, 2-3 internal one. Okay, then you don't need a platform engineering team. Why? We don't even need to discuss it. Because your silo is so big, it almost takes your whole IT organization. And then there's just a little piece beside which someone else can do, right? So this is like where you need to think about how big is the silo in which you're moving as a DevOps, and if there are multiple silos, or if there's too many little applications beside it, which is way more bigger than the silo itself, then you need to think about platform engineering concepts.
Yeah, thank you, Max. That was very enlightening. And then let's have a short break before the next session. You can obviously contact Max on LinkedIn. It's on the screen for last 5 minutes, also on the Twitter, on the GitHub. I'm sure he'll be happy to answer any other questions as well.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and I on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's stars.